Good afternoon, everybody. My name is Nick Thompson. I'm from Schneider Electric, and for the next 40 minutes, I'm going to be introducing you to the latest version of Ringmaster RN2D. ED certificate in time. We would ask you that if you've got any questions, add them onto the chat, and then at the end of the seminar, we will be answering as many or all of questions that we can. If we not able to answer the questions on air, we will be getting published on. I would like to thank you again for attending, and the first segment is a very short video.
Meet David, a Schneider Electric engineer who works on our Ringmaster range. Manufactured at our lead site, our ring main units have built a reputation over the last 40 years for reliability, thanks to our high standards and rigorous testing, making Ringmaster the most successful ring switch on the market. But David has been listening to his customers, and their needs are changing. They're trying to balance increasing global demand for energy with a mandate for decarbonized clean energy. They also need to integrate renewable energy sources and find a way to manage an increasingly complex and decentralized network. That's why David and his team have been working to develop a new Ringmaster that is ready to meet the demands of tomorrow, the Ringmaster RN2D. Features like the touch-proof nickel-coated epoxy tank and a redesigned higher specification cable box make it even safer to operate. Plus, the improved front fascia has an intuitive mimic, which makes it easier to use too. Key components have been re-engineered to increase reliability, like the thoroughly redesigned switch mechanism, which reduces bolts and fixings to minimize the risk of failure even further. On top of all this, it also offers improved internal arc performance. The RN2D still excels in harsh environments and has been optimized with a compact installation footprint and an internal earth bar to reduce the risk of theft. It's smarter too. The VIP 400 relay brings advanced protection features, and because Schneider Electric is developing connected products as part of its commitment to innovation at every level, you can combine the RN2D with our EasyG T300 remote terminal unit to gain access to advanced communications features. And the RN2D supports a wide range of communication formats to help future-proof your network. This makes the RN2D a truly smart RMU, enabling remote monitoring and control, which is compliant with the latest cybersecurity standards. Safer, more reliable, and smarter than ever, RN2D is excellence redefined. That's why David thinks it's the best Ringmaster yet.
So that's just a short introduction to Ringmaster, and these are the subjects that we're going to be covering over the next 35 to 40 minutes. We're going to look at the values of RN2D, what the benefits are technology-wise, what the product offer is all about, and finally looking at a little bit more in depth on the specification. Ringmaster has been around for a good number of years, and today's environment requires us to have electricity on demand. It's become a human right, and typically if we can't switch the lights on or you charge our mobile phones up, we get a little bit upset. The providers of that, or the managers of the network, they're always on the lookout to reduce their losses, whether it's technical or non-technical losses, and no matter what the environment is, they're looking to increase the reliability or reduce any particular issues. Safety is always a byword, and equipment that goes onto networks these days has got to meet very rigorous safety standards, not only for people who will be using and operating them, but also people around them and the plants that they are going to be working in. And then traditional networks, we have power that flows from the power station to the socket, Nowadays, with renewable generation, such like solar and wind, your network managers are now having to contend with power that's flowing in not just one direction, but two directions, which is adding to all their kind of issues. And on top of that, they're looking to reduce their operational costs. Now, Ringmaster or RN2D is the next generation of RN2C. RN2C has been around since 1998 and is the stalwart of the secondary distribution network for medium voltage. The product has been designed with customers in mind, and we've taken what is a very good product to the next level with advanced features. As you'd expect with all products these days, they have to meet very exacting standards. IEC series of standards for switchgear is just one, but also locally for our utilities or DNOs in the UK, in ENA TS 4136 is also a very, very exacting specification for their use. So how has Ringmaster evolved? It's evolved over the years, right from the very early days of switchgear. We've got here in the 70s or earlier than that, we used oil using fuses to protect the transformer. Moving on from there, we had then SF6 gas with two units, firstly with Ringmaster 1.5, and the number there, 1.5, is referring to the current rating of the circuit breaker. As time and technology moved on, Ringmaster 2 was brought out. Instant difference there is the door. The door was from a side hinge to a top hinge, making it a lot more user-friendly as far as operators go when there's inclement weather. Gas as well, SF6 gas, introduced in the early 80s. Still used today, but we have done a lot of work to recognise that higher pressures are not very conducive for leaks, and if we can use as little gas as possible, that's good for everybody concerned. Ringmaster 2C was introduced and launched in the 1998, and C just stands for compact, bringing the size of the unit down to the current size that's on the market at the moment. And then we've now launched Ringmaster RN2D. D stands for differentiated, and it's there to differentiate it from RN2C. Globally, Ringmaster is manufactured in the UK, here in Leeds, and it is the UK market centre of excellence for medium voltage. Other people may know it as high voltage, and it's got a very good reach throughout the world. Notice there that a lot of those countries are the Commonwealth countries, which have got a strong influence within the UK as far as network design goes, but other areas like Peru and Argentina, where they recognise that a unit which is suitable for use of outdoors is ideal for their applications. The majority of Ringmaster will go into the DNO or the energy networks for distributing from the primary 11 kV substations round to factories, homes, etc. Also, you'll find Ringmaster in other applications, large sites such as hospitals, factories, commercial buildings, industry, and also within generation such as solar or wind. What are the benefits of the technology? Well, let's look at our circuit breaker. How does that work? Well, electricity, amongst other things, doesn't like being broken, and that is not uncommon in any application. And on switchgear, we've got to manage an arc which will be struck when we interrupt a circuit. Here is the arc interruption mechanism which is used within Ringmaster and has been very, very successful for nearly 30 years now. You've got three elements. You've got a central electrode, you've got moving blades, and then you've got a copper coil. Well, we've got the breaker closed and on. It sits at the back, the blades sit at the back of the central electrode. When we interrupt the circuit or switch it off, two things happen. The blades will move very, very quickly under for the springs that are driving the blades open, but also it will instantly strike an arc as the blades open. Once the blades are fully open and are home on the contacts behind the copper coil, the arc is then transferred to the inner edge of the copper coil, thus striking an arc. If that arc was then to remain in one place, it would soon degrade not only the central electrode but also the outer coil as well. So using a rotating magnetic field, the outer edge of the arc will then spin and then try and play catch up with the magnetic field. That will then draw it out to then become long, weak, and then at current zero it will then self-extinguish. That has been proven over the years as a very reliable method of interrupting a arc, either during normal operation or during a fault. Now when we move on to the other areas, and this is where the main cables will be connected on the ring, as we can see there with the bushings highlighted. This is where your main cables are bolted on, and traditionally there's been a bushing profile which doesn't meet the latest IEC bushing profile there. We have what's called a Type C. There are others to choose from, but Type C seems to be the most common one, which is used on 11 kV distribution switchgear. The grey bit that you can see there is a metallic earth screen, which is all part of the tank. Inside that bushing, on each of the three bushings, there is a screen embedded, or that's cast into the pole, and it's then connected to a cable which is then going to be used for the VPIS, which is Voltage Presence Indication System. It's only a simple device which allows you a visible indication that's potentially a live circuit. The bushing there can be used for termination using a separable screen, or the more traditional heat shrink or cold fit flexible boot. The DNOs are more likely to be moving on to the Type C separable boot because it gives a more reliable termination. With protection relays, this will be there just to protect the transformer. There are three that are widely available. When we use a true relay, self-powered is accepted and is a standard requirement for ring main units, which Ringmaster forms part of. And these are the new ones. We've got 40 and 45, very, very simple, with an IDMT curve inside there. It's taking self-powered simple protection relays up to the next generation. We've got a display. You can see what current is flowing in there. We can also do a little bit of interrogation, and we will also have an LED which will flash when it detects and interrupts a fault. The more sophisticated, as we can see here with the VIP 400, again it's self-powered. It will give better protection functionality than the VIP 300, which is one of the options with RN2C. You'll get a digital display showing you what load is in the circuit, And also you've got more protection curves available, making it a lot more sophisticated to actually do your protection studies. Also, you now can go back as to what's happened, and it will tell you not only what current has maximum demand as it's seen, but also what current it's actually been under fault conditions. So you can start to do some analysis of what's going on inside or within that circuit. The most popular form of protection, and it is the simplest, is time fuse link. Principle being that the fuse, the two fuses for overcurrent protection, if the secondary current from the CTs exceeds the fuse rating, then the trip coil will operate. And unfortunately, you can only go up to a 1.6 MVA transformer using this form of protection, but it is by far the most popular form of protection that we use here in the UK. It is, not only is it simple to install, but there's a very simple table which you quite simply select your voltage, your network voltage, your transformer size, and then that will give you a recommendation of a fuse that you could use. But that does not do away with a protection study to determine exactly what you want. Earthing, where you connect onto the substation earth. There's still a earth connection there, but it's actually been moved to make not only the unit look a little bit neater, but it's also removing the opportunistic thief, where copper theft inside a substation is a real serious problem. So the main earth circuit is hidden behind the main steelwork with a bar which will stick out at the bottom of the unit, where the substation earth will be terminated on, along with the flexible braids for bonding on the gland plate, glands and transformer. So that's a positive move. There will still be anti-vandal fixings available for those that require them. The main driver on RN2D was to improve the reliability of the switch mechanism. And one of the potential fail points on RN2D was a bolt that secured the drive shaft onto the mechanism. This has been replaced by a spline and circuit arrangement, and other things that have been closely looked at during the development using design failure mode effect analysis were other components which potentially could have failed, and one of those was the travel stop bearing assembly. That is there to stop the spring jumping off of the carrier and ultimately the mechanism jamming and not working. Other things when we started to look at critical components are the three that we've got here on slide. One is the drive pin, which holds the circuit breaker mechanism point in place. That was looked at using DFMA. The side sheet, when we looked at the latest computer and analysis techniques, which weren't available when RN2C was first developed, they discovered there was potential fracture points within the design. So they've done some strengthening work on critical areas of that plate. And the DAT lever, again, you can see there, that's the extreme of the ambient temperature operating, which in the UK will be very rare, but in other areas of the world may be an actual reality. And they've strengthened the pin up by increasing the diameter by a little bit, and that's actually improved the reliability of that particular component. Safety is, as I've already said, is foremost of anybody's mind, and the IEC standards which we work to are very exacting on not only how we test them, but also how we achieve a pass when we subject the units to a test. Now, an internal arc is a very rare occasion, but if it does happen, then it's catastrophic not only for the equipment, but could also be catastrophic for anybody who happens to be in the vicinity of a switchgear which has been subject to that fault. That fault could be one of many things, but we still have to test all our switchgear before we put them onto the market. And within RN2D, there are two areas which need it to be tested. First one is the gas enclosure. If there was an internal arc inside the gas enclosure, then we've got to test it for the design. In this case, we tested it for a fault level of 21 kA. And then we've got the cable boxes, not only the ring switch cable boxes, but also the circuit breaker cable box as well. And they were tested at a low level, whereas the fault levels on the ring would tend to be a lot lower inside the cable box than potentially we would see inside the main gas enclosure. Now, the designation we've got there against the gas enclosure AR is A for authorised, F for front, L for lateral, and R for rear. It's down to the manufacturer what designation we would put against that, and that will be clearly marked on the rating plate on the unit. Now, for the cable boxes, the designation for that is AF with a much lower fault level. Now, with inside the cable boxes, we've got additional construction features to make sure it passes the internal arc testing. And we've got sandwich arrangements inside the cable box. One is a sacrificial plate that is designed to be deployed, and then the arc would then stop at the sandwich material, which is an insulation material, and with the 1 second 1 second test, which it's been tested, it would then would cease. Within inside the cable boxes and also inside the gas enclosure, there are blast points or pressure relief points in the form of flaps in the cable box and a blast plate on the gas enclosure. What else have we got? Well, it is incredibly flexible product with not only our fascia. The current fascia on RN2C, it shows a single line diagram with your switch and the circuit breaker. A study has been done on the fascia to see how we could make things a lot clearer, and the initial reaction we've had from customers who's actually seen the fascia have commented how clear it actually is. The mimics are bigger and clearer, the colours are bolder, and it's instantly recognised what's in service, what's off, and what's going to be in earth. With voltage pressure indicators, they are now mounted on the front fascia rather than inside the drop-down LV box, and they are connected to the screen that's buried or cast into the bushing. This is a much more reliable device over and above the RN2C, which is a garter spring which goes around the bushing, and the VPIS now is one device that goes from 3.3 kV up to 13.8 kV. The VPIS is one of the options. Not everybody wants it, but it's very useful when it's used. Cable testing is something that you need during either commissioning or after you've got a fault on a cable, and it's a UK habit to have a separate cable test device introduced way back in the early 90s and possibly earlier than that with RN2C and following on with RN2D. It's a drop-down star bar for your ring switches underneath, which then gives you access to the circuit. You can only drop the star bar down when you get circuit earth. Listening to customers' requirements on cable testing, an additional feature of a bent copper plate at the side of each bushing there, where it makes it easier to clip your test set onto the test point rather than having it on big stub stem that is exposed only when the star bar is opened. This is an additional benefit for anybody who prefers to keep the test set connected onto the test point whilst they're closing the star bar and then removing the test set clips once you've got the star bar closed. If the unit is ordered, if the RN2D is ordered without these bent plates, then it's a very simple retrofit requiring very little downtime to modify it to this user-friendly feature. Smart, and we talk about smart things an awful lot, and networks are becoming smarter and smarter, and the level of information that we now require is far greater than we would have ever wanted or wished for 30 years ago. In an end user to be able to remotely operate and communicate with an RN2C or an RN2D, you need a remote terminal unit. This will be then connected to some form of communications device. It could be fibre optic, it could be Wi-Fi, it could be Ethernet, or it could be license-free radio, or whatever is the standard for that particular area. The T300, the ECG T300, is the latest one in a long line of ECG RTUs, and this is moving into the modular arena with modules that plug into a head device, which is then powered from a battery and ultimately an auxiliary power supply. This is only for communicating and operating the RN2D switches or circuit breakers. It does not affect the protection. It is very much open-ended, and you can communicate to it locally inside the substation using Wi-Fi access. And as we all become more concerned about cybersecurity, it's to the latest IEC cybersecurity specification. Add that to a RN2D, and you've got not only an RTU, but you've also got a very advanced ring main unit, which will then give us a smart ring main unit, or a smart RN2D. This allows you to not only easily retrofit or remote operation, but smart operation as well. When we look at the various product features, the architecture and the look of RN2D has changed. Well, the look has changed a little bit. The method of operation is no change at all. The gas enclosure looks very, very similar, with the exception of Type C bushings, which are now. But we've still got the various standard things like gas pressure indicator. Motor kits are still available. It's the same motor kit that is used in RN2C. Still got a front cover with a mimic on it, but an enhanced front cover. And also we're now adding the QR code onto it. Long term with the QR code, we're looking at linking individual QR code to that individual serial number on the RN2D, so it will then, once you fire it up, it will take you to a secure cloud-based server with all the relevant information. The range configurations haven't changed in too great a detail, and we've got our standard freestanding cable connected onto the circuit breaker. There is the very popular transformer mounted, and this is showing a unit substation, and then there is also the extensible version, transformer mounted, but also the cable connected extensible unit as well with a Ringmaster range attached to it. This configuration gives you the benefit of having two feeds off of one point on your ring. A popular unit for local control of a transformer at the end of a radial feed is Ringmaster range non-extensible. You get the benefits of main circuit earthing on the main incoming cable, but also the lower fault rated transformer earthing for when you want to do maintenance on the transformer or the LV side of the transformer. You can locally earth the transformer without having to earth down from the main feed circuit breaker. Ringmaster range also comes in as an extensible version where you can make up a multi-panel switchboard. The only limit there would be the current rating of the bus bar and the fault rating of the bus bars as well. Leading on to a unit which is an extensible RN2D or RE2D. This is a double extensible where you could couple two Ringmaster RN2Ds together side by side, and then we've got the top entry both on either on the ring switches or the circuit breaker or both. That is for where the cables would be coming down from the ceiling, typically a basement substation. Under that application there, that would only be on an indoor installation. Splitting them down now into D, there is a various series of catalogue numbers. Typically will be RN2D T1, which we can see on the right hand side. The /21 is designating it as 21KA. Metering units, these have just got metering VTs and metering CTs inside the box, and they can be close coupled to either the transformer or the RN2D. This will be bolted onto a flange, which will be on the RN2D circuit breaker. And then we've got our Ringmaster range, which has got not only switch and circuit breakers, it's also got non-extensible or extensible. One point to note, you will always get a 630 amp switch, whereas the circuit breakers you got the option of 200 amp or 630 amp. The specification, some slight changes to RN2C. We've now just only got one fault level for 21KA, both internal arc and that's for the gas enclosure, but also 21K short time withstand at 3 seconds. The mechanical endurance still remains at 2,000 operations for the circuit breaker and 5,000 operations for the ring switches. And the weight has gone up slightly, but not significantly. So, the features. Through the extensive analysis that we've undertaken using technique and software which was not available when RN2C was developed and launched, We're taking the reliability of RN2C upwards. We've reduced the failure points. They are potential failure points. Moved to a Type C bushing, which is becoming a standard requirement now with more reliable cable terminations. Protection relays, like mobile phones, they're getting more and more powerful, but still requiring the self-powered functionality. Safety, it's fully internal arc tested for both the gas enclosure and the ring switch cable boxes with blast points at the back of the cable boxes on the ring switches. We're maintaining the earth screen throughout on the gas enclosure, and when you're using a earth screen separable connector with earth screened cables, you now get a fully earth screened system. Ringmaster will continue as it has with its pedigree of being very robust in very many harsh environments, be it from a contaminated environment to an application which may cause issues when you've got a polluted environment. Flexible, it continues to be very, very flexible with the cable test that has now become market standard in the UK. We made that a lot more flexible and better for users. You've got an easy pick, which you can easily recognise what you can see is going on. It stands out. It continues to be easy to install and easy to maintain. The actual footprints, the fixing positions of the feet and the centre height of the circuit breaker and ring switch bushings have not changed. So you can take one out and then put a RN2. You can take an old RN2C out and put an RN2D in with very few modifications. The extensive list of options and features still remain. And then it's smart, and being a smart network is very much on the forefront of not just the DNO line, but also smaller sites where they may need directional fault passage indication, where they need to have advanced security on their RTU, and also if you're worried about cybersecurity, then it complies to the latest cybersecurity standards. So that's the finish of the formal presentation. If there are any questions, and I haven't actually seen, I can see one or two, and I will answer the questions as best as I can at the moment. And the first one is from Peter. It's very much a unit which is like RN2C, and it won't actually interfere with the tap changer when you've got it mounted in unit substation. We've looked at that very, very carefully. Even though it's slightly wider with the cable boxes, we've been mindful that we can't obscure the tap changer when you need to either set it up or do any changes. So I hope that satisfies somebody in mind. The D stands for differentiated. At the beginning of the project, we want to call it RN2C+, but the DNOs don't like any plus or other kinds of symbols because it doesn't work very well on their asset register. So D stands for differentiated, even though it is the next letter in the alphabet, but D is definitely for differentiated. Just to remind you, it is CPD accredited, and it'll be about 10 days before you get your certificate. We'll be sending them, well, I won't be, but Voltimum will be sending them out by email that you've and that'll be the email that you've registered on the webinar. There is a PDF version of this presentation which is available to download at the end. Has anybody got any more questions? Oh, another one's just popped in. When we've got neons, or that's the old technology, VPIS now uses LEDs, which are far more reliable or robust. You can actually now have them on the circuit breaker when it's transformer mounted. That's due to the screen that's cast into the bushing, which makes it a far easier way of having the VPIS. VPIS for the circuit breaker will also be on the fascia of the RN2D. Is there any further questions? Phase rotation indication, no there isn't. If you need to do phase rotation or phase checking, you would need the appropriate FISTRA device and the VPIS is fitted on the unit. That's the only means that you could have for phase rotation or phase checking. Short circuit at 20 kA. The internal arc rating of the cable boxes has been tested at 13 kA. Obviously, the fault studies would have to be done by the appropriately qualified person to determine what fault level would be at that particular point. For short circuit, this is current withstand. It's still rated at 21 kA, short circuit, short time withstand at 3 seconds, so that shouldn't affect the risk. Thank you very much indeed. Well, if there are no further questions, I will finish the event. Just as a reminder, you will get a CPD certificate within 10 days. If you would like a PDF copy of the presentation, it's available to download. Once again, thank you very much indeed. I will now end the seminar.